Look at a different geome in this video, namely the one that is used to prepare scatter plots. So we're going to look at the relationship between two variables. We'll continue working with the iris data set. So let's set up a new plot. So we'll call ggplot, and we're going to use iris. And this time what we're going to do is to use two different data points or variables. So we'll do petal width and petal length. You can see there. So again, we've got the first part of our plot set up because we've identified the aesthetics, but we haven't identified the geome. So we need to add that. So our geome is going to be the point geome. So we'll make sure we add our parentheses there. And I'm just going to go ahead. So I'm not going to. I don't like the gray background that much myself, so I'm just going to go with the black and white theme. So let's run this, and there we have our nice little scatter plot. So you can see that that's a good start, and we have all of our data are shown here. So that's a hallmark of a good graphic, and according to the Grammar of Graphics philosophy. And again, I could go through and I can change the X label and the Y label, and I could add a title, do all that. We won't bother to do that in this particular example, but you could do that quite easily. But one thing that I might be interested in doing is taking a look at how I might represent a line or a curve through the points. And what I want to do now is to have R draw a relationship between the two variables. So what I'm going to do is to add a different geome to my plot. So add a smoother. So just call it geome smooth, and run that. And now R has created this curve that goes through all the points. By default, R uses a type of nonparametric regression called low S regression, locally weighted regression. Most people are not going to typically use the low S regression because you can't really put a formula on it. You can't figure out what the formula is, like if you had done a line, but it still shows the trend of the data. And what you can see is it also is plotting the 95th percentile, the confidence interval around the line, so the 95th percentile. So we know that the true value, 95% certainty, lies somewhere in here for this value of x or this value of x. It's a little smaller. What you can see is pretty typical. As you get to the ends of a distribution, the uncertainty becomes a little bit higher. So it's not unusual to have a greater confidence limits toward the distribution's ends than toward the middle. But what we might prefer to do is to, instead of using the low S regression, we might want to just use a regular old linear regression. And so we can specify that. We just put that in right in method, and then we have to put in parentheses LM for linear model. And now we get something that looks a little more familiar with a nice linear regression right through that. By the way, if I don't want to have the confidence interval there, I can get rid of that just easily. That happens to be called the, tell you what, let me go to the next line here so we have enough space. But that confidence interval is called the standard error. There's actually two standard errors. But what I'm going to say is that I don't want it, so I'm going to say false. Oops, I got to run both of these lines. Sorry about that. And so I got rid of it that way. If you don't want the confidence interval there, I think it's sort of nice to have it myself, but it's sort of up to the individual as to whether or not you would prefer to have that or not. And what we can do is to change other aspects of the graph as well. As an example, if I wanted to change the color of the points, I could do that, and I would use the geom feature here because I'm not mapping the value of the colors to of the data to a particular color. So I can just set all the colors to all the points to a particular color that I might choose. And just as an example, let's just say color equals, and I'll just see what I get for just plain blue here, and run both of those. And so I've got all blue points there that you can see. If you go to the website that the URL is on the Moodle page, then you will see this particular page. And what you can see is that we can specify the shape of the points according to these numbers here. You can also change the nature of the line that you draw through points. But we're going to concentrate here on the shape of the shape of the points. And so what I might want to do is to alter that in my developing diagram here. So we're going to go back to R here, and I've already specified I want my color to be blue, but let's say that I want my shape to be equal to triangles, and you can see that I just use that from here. So I've got upward facing triangle there, so use that. And I can change other aspects of that as well. I can change the size if I want to make them a little bit bigger, and you can just experiment with these numbers. But now my points are really big, so I obviously don't want them that big. And that's perhaps even too large as well, because there's a lot of overlapping of points there. But sometimes having the points overlapping isn't bad, because what I can do is, I'm going to have to what I'm going to do is to take this away and put it down here so we can see everything is going in here. What I can also do is to change the transparency, so that when so you can see through the points, and if you get really dark blue, that means you've got a number of points that are overlapping with each other. So I'm going to make my transparency about 50% normal, and now so I just cut and pasted so I could show you all the data that went into the geom point parentheses here. So I've changed the color to blue, I've changed the shape to triangle, I've made the size 4, and I've also made the transparency 50%. So let's run this. Keep running all the lines, and so you can see that when you don't have many points in a particular place, you can see through partially. So the point shows up fairly light, but when you have a whole lot of points right together, it ends up pretty dark. So you end up with a cluster of points here and a cluster of points there. So you can play around with the shape and size of your points. Maybe that's a little bit better. So it's up to you. There are all sorts of variations that you can change, and of course you can also change the font size and other aspects as well. But remember, when we had the iris data, we actually had 3 different species. So we can use our faceting in this as well. So what I'm going to do is to add a facet, and remember, ggplot doesn't like to have a plus sign at the beginning of a line, so I'm going to hit plus here. I'm going to add a facet, and I'm going to do facet grid, and I'm going to do period, number of rows, and by column I'm going to have species. So now I'm going to run all of these, all my plot here, And so I've got 3 different columns, and I've got just 1 row. And it looks like the 3 species are pretty different. These are relatively small in terms of petal width and petal length. These are really big. So it may be that I want to do it the other direction, right? So I can just reverse my faceting. So instead of having species there, I have 3 rows, 1 column. So we'll highlight all of that and run it. And so I've got that diagram there as well, that three different plots. So it becomes pretty obvious of the distinction between the 3. And you can also see differences in slope, it looks like, for the 3 different types of flowers of irises. So it might be worth additional investigation. So there's some of the many things you can do to take scatter plots and draw lines through them with the smoothing geom, and modify the shape of the points, the color of the points, the transparency of the points, to make a really nice looking graphic.